47 and 52. And I'm going to do 45 and 47 doing both the washer and the shell. And number 52 will be on the test next week. So 45. So first step, make sure you draw the picture correctly. Y equal x cubed. And then y equal 4x. Something like that. Oh, but we're only doing the region in the first quadrant. Okay, and here is the point 2, 8, right? You can see from inspection. So the first one, revolve it about the x-axis. Well, if you draw the rectangle vertically like this, if you revolve it around the x-axis, you're going to get a washer like that. So washer pi, big R squared minus little r squared dx, since the rectangle is vertical. So big R goes from the center to the outer edge. So to find a vertical distance, you go top minus bottom, so that's 4x minus 0. Little r is this distance here from the middle to the inner edge. So for a vertical distance, you go top minus bottom, so that's going to be x cubed minus 0. And then you add up all of these washers from 0 to 2. And this integral looks easy to do, so I don't need to do it for you. And then part B, revolve it about the line y equal 8. That's up here. Let's just draw the picture for that. So it looks like this. So take this region and revolve it about the line y equal 8. Y equal 8, which is that. So again, if you draw the rectangle vertically and you revolve it about that line, you're going to get a washer. By now, you guys should be good at drawing these. So pi big R squared minus little r squared dx, since the rectangle is vertical. The rectangle determines whether you have a disc, washer, or shell now. You need to draw this rectangle in. So big R is this distance here. And how do you find this vertical distance? Top minus bottom. So that's 8 minus x cubed. Little r is the small radius here. And to find a vertical distance, again, you go top minus bottom. So that's 8 minus 4x. And then you add up all of these washers from 0 to 2. Since you're doing it with respect to x, you go from the x coordinate here to the x coordinate there. So whatever the region is, that's what's going to determine your limits of integration. If you're doing it in terms of x, you go from x1 to x2. If you're doing it in terms of y, you go from y1 to y2. And that integral, you can just multiply that out to do now, and that doesn't look too difficult. Okay, now I'm going to do these same problems, except I'm going to do shells. Even though the homework, they want you to do washers, I'm just going to show you shells so that you guys get used to it. 2, 8. So this is y equal 4x, y equal x cubed. Okay, you're going to take this region and revolve it about the x-axis. Now, to get shells, you need to draw the rectangle horizontally so that it's parallel to the axis of rotation. So, and whenever you do shells, this point, you know, where the rectangle meets the curve, label it xy. Because again, remember from Algebra 1, if you label a point xy, this is x and that's y. Okay, so formula for shell, 2 pi radius height dy, and it's dy dy because I drew the rectangle horizontally like that. So the radius of the shell is this distance right here. That's the radius of the shell. And since we labeled that point xy, that's y. Anyway, you need everything to be in terms of y because we're doing the integral in terms of y. And then the height of the shell right there, again, it's a horizontal length, so you got to go right minus left, but you need to solve for x. So in this equation, you have to solve for x. X equals the cube root of y. And in this equation, you got x equal y over 4. So when you go right minus left, it's going to be cube root of y minus y over 4. And then you add up all of these shells from, and since we're doing it with respect to y, 0 to 8. And that integral you guys can do, just multiply it out. Okay, part B. Revolve it about the line y equal 8 over here using shells. So that means you need to draw the rectangle horizontally again. Boy, that's an ugly shell. And again, label this point over here xy. Because then y will be this distance there. Okay, so 2 pi radius height dy. The radius is this distance right there. So you can think of it as top minus bottom, so that would be 8 minus y. Or you could just use common sense. From here to here is 8. From here to here is y. Therefore, that has to be 8 minus y. And then the height of the shell is simply the length of the rectangle, which is right minus left, which is the same as the right minus left in this problem. So that's going to be the cube root of y minus y over 4. Add them up from 0 to 8. Just look at the region. The y coordinate there to the y coordinate there. That gives you your limits of integration. And that one you just multiply out also. So you guys, I know you guys can FOIL. Okay, number 47. Okay, region in the first quadrant, bounded above by the curve y equal 1 over x, 1 over root x. So here's the point 1, 1. See how you plot easy points? On the left by the line x equals 1/4, so that would x equals 1/4. And below by the line y equal 1. So I guess it's this region right here. And we're revolving it about the y-axis. And so they want part A, they want you to use a washer, and part B, a shell. So part A, now if you want a washer, you have to draw the rectangle horizontally because we're revolving it about the y-axis. It has to be perpendicular to the axis without touching. So if you try it, oh, that's going to be ugly. Ooh, that's the washer. Pi, big R squared minus little r squared dy, since we drew the rectangle horizontally. Okay, so since we're doing a horizontal rectangle, we need to solve for x. So in this equation, to solve for x, you're going to get root x equals 1 over y, so x equals 1 over y squared. So x equals 1 over y squared, and the one on the left is x equal 1/4, so that's good. So the big radius goes from the middle to the outer edge, so right minus left. So that's 1 over y squared minus 0. The inner radius is this distance right here. So right minus left, 1/4 minus 0 is 1/4. And then you add up all of these washers from, look at the region, from the y coordinate down here to the y coordinate up there. So it's from 1 to, what's the y coordinate up there? Well, if the x coordinate is 1/4, if you plug it into this equation, you get the square root of 1/4 is 1/2, and 1 over that is 2. So therefore the limits are going to be from 1 to 2. You go from y to y. Yeah, that's an easy integral to do. Okay, part B, they want you to do shells. Okay, so the region looks like this. Let's reach out the picture. Boom, boom. Okay, now, if you want to have shells, then you got to draw the rectangle parallel to the axis of rotation, which means it's a vertical rectangle, which means you're going to do it in terms of x. And if it gets revolved about the y-axis, you're going to get a shell, label that point xy, as we normally do with shells. So the volume of, that's an ugly shell, 2 pi radius height dx, since the rectangle is vertical. The radius of the shell is that distance there, which is x, right? Again, remember, if you label a point x comma y, x tells you how much you come out that way, right? And the height of the shell is simply the length of the rectangle, which is top minus bottom. So remember, the equation on the top was y equal 1 over root x, and the equation of this one on the bottom was y equal 1. So top minus bottom is simply 1 over root x minus 1. And then you add up all of these shells from the x coordinate over here to the x coordinate there. So that would be from 1, 4 to 1. And down another one, you just multiply out. So that was kind of easy. Not many trig ones in this one until you get to the review worksheet, which you guys need to download. I'm just going to put it on the website and you guys download it. In fact, it's already there. Just look up, I think it's under volume review worksheet. That's going to be a practice test. And then 52. Okay, this problem is on the test. This problem has been on the AP exam for the past several years. You need to know how to do this. This is a related rates problem, by the way. Okay, y equal x squared over 2. This is a parabola opening upward, kind of wide, between y equals 0 and y equals 5. So here's 5 right there. Revolve it about the y-axis, and you get a bowl. So poof, woof. You get a bowl. Find the volume of the bowl. Now in this problem, even though they give you the equation as y equals x squared over 2, let me make sure that's right. Yeah. You wanna do horizontal rectangles because see they gave you the y coordinate is 5 there, so your integral would be from 0 to 5. Y down here to y up there. And then look, not only that, is when you revolve it around, you're going to get a disk, which is the easiest of the 3, right? So that means you need to solve for x. So 2y equals x squared, so x equals root 2y. Okay, so that would be the equation of this part right there. So what's the volume of a disk? Pi times the radius squared dx, or dy, since we drew the rectangle horizontally. And the length of the rectangle is the radius, so you just go right minus left, so it's going to be root 2y minus 0, which is just root 2y. Look how beautiful that is. And then you add up all of these disks from 0 to 5. And that will give you the volume of this, what do they call it, a bowl? Punch bowl? Whatever. Okay, let's go ahead and compute this. Pi, short of pi on the outside. And then when you square this, you're going to just get 2y, so you can throw the 2 on the outside as well. And so you have the integral from 0 to 5 of y dy. But the antiderivative of y is 1/2 y squared from 0 to 5. Factor out the constant, 2's cancel out. So you get pi times 25 minus 0, which is 25 pi. And that answers part A. Find the volume of, that's the total volume of the bowl. B, now if the bowl is being filled with water at a constant rate of 3 cubic cubic units per minute. dV, that means dVdt is equal to 3. Remember related rates? How fast will the water level in the bowl be rising when the water is 4 units deep? So in other words, if this is the height of the water, we want to be able to, we need an equation that relates the volume with the height. In other words, if you know the height of the water, can you figure out what the volume of the water in the bowl is? Yeah. So the volume of the water in the bowl is the integral from, see, we did the integral from 0 to 5, that's the volume of the whole bowl. Or what about if you know that the water level is at h? So you do the same integral, except you're just going to go from 0 to h instead. Does that make sense? Right? You integrate all of these disks from 0 to 5, you get the volume of the whole bowl, but what if the water is only h feet deep? Then you just do an integral from 0 to h instead, where h is somewhere between 0 and 5. So we're going to compute this integral here, and instead of reinventing the wheel, just go to this step here. Pi y squared from 0 to h instead of from 0 to 5. So this is going to be pi times h squared minus 0. So that means the volume of the water in the bowl is equal to pi h squared. So for example, if the water height was 1, then the volume would be just pi cubic units. If it was 2, it would be 4 pi cubic units. If it was 3, it would be 9 pi cubic units. If it's all the way up to the top, then it would be 25 pi cubic units, right? So that's like a function that relates the volume with the height. And that's always the first step, right? Remember related rates? It's a 3-step process. Write an equation that relates the variables, take the derivative with respect to time, and then plug in numbers. Okay, so we got step number 1. We wrote an equation that relates the volume with the height. Now we take the derivative with respect to time. So dV dt, or you can write v dot, remember, is equal to, throw the constant on the side, and the derivative of box squared is 2 box to the first times the derivative of box, which in this case is dH dt, because the box is h. We're taking the derivative with respect to time. Anyway, it says, how fast is the water level in the bowl rising when the water is 4 units deep? So if you don't multiply it by the derivative of box dH dt, that's the thing you're trying to find. How do you even find it if you don't have dH dt there? So in order to solve for dH dt, you need to know what dV dt is, which we know is 3. And we need to know what the height of the water is at the moment in question, and I think it says 4. Yep. So you plug in 4 there, and now you can solve for dH dt. So 3 equals 8 pi dH dt. So therefore dH dt is equal to 3 over 8 pi. And whenever you do related rates, you always give units, right? So, and again, if you don't know how to figure out the units, look at this. Height over time. How is the height measured in this problem if you have to measure height? It would be units, and time is seconds, so units per second. And there you go. So you're going to get this problem on the test. The only thing that's different is I'm going to change this equation and change that number, right? And of course, these other numbers are going to change too. So make sure you know how to do this problem. You're going to see this again on the practice test, the review worksheet, so make sure you can do it. Goodbye.